Thanks everybody for coming out this afternoon and logging into our webinar here. We're going to be going over the next half hour, maximizing machine tool value. It's presented by myself here, Ian Scribner, with CamLogic. And with that, we'll go ahead and get started. So who is CamLogic? CamLogic was founded back in 1995 by Jim Carlisle, the owner here. A little over 16 years of double-digit annual growth. CamLogic provides cutting-edge products and services, and our main value is dedicated customer service. That's what we like to set ourselves apart with the competition. CamLogic has sort of a three-prong approach. There's three different groups, let's say, of CamLogic, one of which is the 3D scanning division of CamLogic, where we come on site. We provide either scanning services or hardware to different customers, prospects. The other portion of CamLogic, the CAD, CAM, or Siemens portion, that's what we're going to be going over today, obviously with the NX CAM and CAM Express. And last but not least, we also get into 3D printing and rapid prototyping through 3D systems. So jumping into what we're here to talk about today, NX CAM is well established in the industry. It's been around at many customers in nearly all industries across the world. Customers vary from the smallest machine shops with just a single seat or license to an international company with multiple seats, hundreds of machines, and all areas such as automotive, aerospace, machinery. We're also closely aligned with the Siemens Motion Control business unit that many of you will associate with the Siemens Sinumeric controllers. We're going to be discussing that a little bit here as the webinar rolls on. So NX offers a wide range of capability. Generally, we divide these into three areas. Mold and die, typically your 3 to 5 axis machines, high-speed areas. We also get into the prismatic parts. This covers your general machining, and especially the kind of parts found often in the machinery industry. Maybe get into some of the Morisiki MT line with mill turn or live tool capabilities. But we also get into complex parts with NX CAM, which typically associated with aerospace, power generation, medical devices, cases where it's more usual to see continuous 5-axis machines. So this is one of my more favorite slides of this deck here. CAM is a critical element to the entire manufacturing part. For instance, customers, we've seen it where our companies or our owners will go out and they'll spend a good portion on a machine tool that has a great controller, maybe spend a little bit less on our cutting tools, and then expect us programmers to just program it manually and expect the machine to be running at its fullest capability, right? We see this far too often. Where NX CAM falls in, obviously we look at it from the standpoint of the CAM software. A good, strong CAM software kind of makes up the entire pie. It's a piece of, it's an equal component to the entire pie. So the main topics we're going to be going over today, advanced programming capabilities, the programming automation, where the rubber meets the road with the post-processing and simulation, and also programming productivity and integrated solution. So NX CAM offers a wide range of in-depth NC programming capabilities that allow us to address many tasks using one system. So all the way from a 2.5 axis clear down to multifunction, NX CAM pretty much offers a tool or solution that can program primarily any type of machine that you have out on your shop floor. So high-speed machine strategies, is an important capability, and obviously in the mold and die, as well as into the prismatic and complex part machining. The high-speed roughing in NX maintains high metal removal rates while managing tool loads. You see in our screenshot here, this is represents some of the trochoidal tool paths but also some of the capabilities that NXCam provides in a high-speed environment would be automatic acceleration, deacceleration, also corner smoothing, Z-level optimization. The list goes on and on, but this one gives you just a kind of a broad overview of some of the areas that NXCam excels in. The streamlined toolpath was introduced back several years ago. This allows you to create smooth flowing toolpaths that can be set to follow the critical contours or features of a part using simple guide curves, which you can see in our screenshot here. The system can compute the toolpath even over imperfect CAD surfaces, where we see on this part here, the surface flow breaks up a little bit, but NXCam ignores that and provides a nice clean cut over those surfaces. The smooth flowing cutting pattern results in fine finishes, obviously at a high feed rate, which then decreases the time on benching the part. NXCam also provides a customizable machining database that enables you to manage and apply proven data to associative toolpath operations. Most every CAM software is going to come with a cut data library that is provided by a third party. This is actually developed by Siemens internally. They tend to take it a little bit of the step further, where it's not only going to calculate based off of your tool diameter and how many flutes and material, but it's also going to accommodate to what sort of toolpath you're providing, whether it be a finishing routine that obviously we're going to speed up our speeds and feeds for versus a roughing routine. We can take it a little bit further than what you can get out of just a standard cut data package. NX achieves a superior surface finish by ensuring that data points on adjacent passes of the tool are properly aligned with synchronous point distribution. You can see in the markings overlaid on the example here to the right an exaggerated representation of the data point spacing and differences it can make in the finish. We see this far too often with some other CAM solutions out there, where a finish path just isn't quite what you would expect out of a tool like NXCam. And that's because we do what is called a synchronized point distribution throughout that entire surface. NXCam offers a complete range of machining capabilities for the latest multi-function machines to support simultaneous multi-axis operations. You're using a graphical display, which you can see up above the machine tool here, provides interactive control for machining sequences across multiple channels. This allows the users to keep track of the in-process state of the workpiece is a critical component of effective mill turning. NXCam will automatically generate an in-process workpiece and provide a seamless transfer of workpiece from one turret to the next. Or I should say, sorry, one spindle to the next. NXCam has been established in the 5-axis capabilities longer than most any other CAM system. That's truly where NXCam, let's say, cut its teeth, where they're in the 5-axis environment. For complex parts, typically aerospace, power generation, NX offers a highly flexible approach and a range of tool axis control options for 5-axis machining. For the case up in the right-hand corner there, where you have a part with multiple pockets with canted walls, it's necessary to select the pocket floor only once, and the system can create the finishing toolpath for all the walls. So in an area, like that part up in the right-hand side, other CAM softwares with all those different pockets, you're going to be doing a ton of picking. With NXCam, they simplify it. All we need to do is select it one time. We'll select one floor, and it's automatically going to determine the walls and calculate the toolpath accordingly. So in this image here, this toolpath resembles a traditional fixed axis toolpath. The system constantly looks ahead for tool holder collision. This is more in the 3-axis, 5-axis, or more in the tool and die. We're starting to see more and more companies try to use smaller tools while using a 5-axis machine. In this instance, when none is encountered, a 3-axis toolpath is output, and that's where you see the green tool and tool holders. When a potential collision is anticipated, the tool axis is gradually tilted away from the collision area. this thus results in a 5-axis toolpath. And real quick, we'll show a quick demonstration on how this works.
In this demonstration, we'll show how we can apply the 3 to 5-axis conversion or automatic tool tilting function to allow us to reach deeper into cavities with shorter tools while still avoiding collisions. We have a part here with a fixed axis finishing toolpath, which will run in a simple verification mode with the automatic collision checking turned on. As we expected, we'll see that there would be a collision with the part if we use this shorter tool. See in the verification check that we have a collision between the holder and the part on both sides of the cavity. In this case, NX turns the toolpath red in the collision zone. So to allow us to machine this cavity with the shorter tool, and assuming we can run the job on a 5-axis machine, we can select the automatic tool tilt option. As we do that, we can set or change various clearance or maximum tilt angle parameters as needed, and then we recompute the operation. Now, as we run the verification again, we can see how with this option turned on, the tool will be automatically tilted to avoid the collisions. The remaining area of the toolpath will be the same as the fixed axis method. This approach is an easy way to start applying the value of 5-axis machines in cases where you've been using fixed-axis techniques.
All right. So Machinery Solution, which was recently added new functions that are designed to make it easier and much faster to program prismatic parts. Obviously, 2.5-axis machining tends to be the most mundane and also some of the more tedious work. So with some new enhancements in NX 7.5, the software uses the full 3D model intelligence of the system to allow the programmer to quickly define cutting volumes. We make use of an advanced in-process model definition to support multi-stage machining and currently adding advanced support for multi-part setup. NX offers a specialized 5-axis NC programming operation for complex multi-bladed rotational parts such as blisks and impellers for aero engines, turbo machinery, and power generation equipment. These complex parts can feature curved blades with undercuts and multiple splitters. Again, we have a quick demonstration to show what we're talking about with the ease of use with NX 7.5.
In this example, I'm going to show you our special software for machining or programming the machining of multi-bladed rotational components such as this impeller that we have here. The system is able to recognize the special kind of geometry that we associate with this kind of component, understand that there are certain blade faces, blade edges that can be recognized to build up the entire geometry model of the entire component. Once the geometry is understood by the system, when we go on to the programming methods, in this case starting with roughing and then finishing, blade finishing, starting here with the roughing operations, a variety of methods of setting up and interpolating the roughing sequences here and providing offset positions relative to the geometry. The system then, here just seeing a quick toolpath verification of that roughing sequence between the main blade and around the splitter blade on this cutter. The system understands that because of the size of the cutter we used in the initial roughing operations, there's some material left between these the main blades and the splitter blades here, and it sends in a smaller cutter to remove that remaining material, the rest material. Then moving on to the finishing operations, a range of finishing processes here for different sides, parts of this special geometry. The system then creates the finishing toolpath for each of the blades. And then at the end we're post-processing this and showing it displayed in our integrated G-code-driven machining simulation inside NXCAM.
So now moving on to the programming automation, which this is where we tend to start looking at some of the feature-based machining portions of NX. So the latest NC programming automation technologies in NX CAM can help improve with your manufacturing productivity. We can see up to 90% on programming time saved by automating routine tasks. This is where feature-based machining is a great example of programming automation that can lead to greatly reduced programming times. NX CAM can recognize a wide range of machining features on a 3D model. It doesn't necessarily matter either where the part comes from. This could be an imported step file, Parasolid. It could come from systems like Inventor, SolidWorks, Solid Edge, and also obviously with NX. And this technology can automatically select and build the machining operations for those recognized machining features. The system allows for toolpath and tool change optimization prior to the final output. When using an integrated solution, though, with the NX CAD as well as the NX CAM, we can take it a step further. And the feature-based machining and the ability to recognize machining features on a part model, we can look at an NX CAD model and read product manufacturing information, or what's also called PMI. That's been added by the designer as a 3D model annotation. We can look for surface finish, dimensional and positioning tolerances as data that could affect the selection of the machining process and tools. For example, a different level of tolerances could mean that we need to select a different machining method, or perhaps grab different tools to accomplish the machining process. And again, with that, we'll show a quick demonstration of how PMI and NX CAM can work together.
In this example of feature-based programming automation, we're going to ask the system, NX CAM, to look at this component and to recognize the features that it can see on that part, and then to create the NC programs automatically for those features. So the first part of the process is for the system to look at the geometry and to find the features based on a range of features that are built into the library already. And users can add more features for it to recognize. The system will look at the dimensions and tolerance data as well and pick up that when it's attached to the features. Here on the left, the system has already identified this wide range of features here and displays them in the feature navigator. And we can select any of those features and ask it to display extra attribute data, lengths, dimensions, other information that is found about those individual features. We could ask the system to program all the features automatically, but here we're going to select just 4, 2 holes, 2 pockets, and ask the system to create programs, NC programs, for those 4 features for this example. The system does that, we ask it to process it, and it puts together a sequence of operations based on the operation sets that are built into the library, and it does that automatically. We open up these 2 holes here and look at the individual operations here. We'll see that there are 3 machining steps in one of them and 2 in the other. This is because the system has recognized that in order to machine one of the holes, we have to add an extra finishing operation to meet the tolerance requirements that were attached to that hole on the model.
All right, so we've seen there how it came in and automatically changed based off the tolerances that it pulled from the PMI. Some other tools that are inside of NX CAM that help for programming automation. For everyday common tasks, you can build process called wizards using easy-to-follow steps. These wizards can make complex software settings based on simple user selections. Wizards are easily available from the NX menu, so you don't have to be a programmer in order to actually create these wizards. Where these wizards also come into play is saving that the knowledge that you have, let's say, from some of the old-time programmers. Keeping that wealth of knowledge within inside the company even after they move on or maybe retire. So next we're going to move into the post-processing and simulation. Again, this is where the rubber meets the road, right? When we can make pretty parts on the computer screen, but we have to obviously be able to post-process it and send it out to the machine tool. With each new job, there can be a lot of time spent on the shop floor, often on the machine itself, checking, testing before the part is ready to be cut. By providing good output from the CAM system, we should be able to reduce this time and efforts and still avoid machining mistakes. This is even more important as machines become more advanced with the IntegrX line from Mazak or the Morisiki NT line. With multiple machining options going on, it's harder to be certain of what the machine will do just by inspection of the G-code. Inside of NX, the post builder is provided as a core or standard part of NX CAM. It provides an easy way to build and edit post processors. Of course, we use this tool ourselves when we build post processors for our customers, but many customers will also use the NX post builder to create and edit their own posts. We also maintain a library of posts that customers can access online from the Siemens PLM Software Global Technical Access Center. And right around 200 to 300 different post processors are available on this website, and obviously can be downloaded at any time based off of machine growth, different machine tools being purchased at different times. NX CAM also provides an optimized sinumeric post processor that can automatically select key control settings based on machining operation data. A special menu inside of NX CAM enables you to select key functions on the sinumeric controller. And although we can post to pretty much any sort of post processor, since Siemens develops NX CAM and obviously the sinumeric controller, between that relationship they can go a little bit up and beyond where most CAM softwares can communicate with, let's say, a controller. And we'll show this here in a quick example.
This is a demonstration of support for sinumeric machine cycles and special commands in CAM and CAM Express. Let's start by looking at a tapping operation. If I were to post-process this through a typical post, we would see fairly standard output, G4 tap cycles, DNR, basic G-code. However, if I take the same operation and post-process it through the new sinumeric post, we see a lot of additional information, not only commentary data, but variables being set for the sinumeric control based on information extracted from the operations of the CAM system. We have things like commands for the triary. We have commands for the orientation around the work coordinate system and the axes. Several Siemens-specific things are built into this to take advantage of the control functions. Let's look at a milling operation that does some high-speed machining. In this case, let's post-process it first through our regular post-processor. Again, standard G-code output. Same operation, we'll post-process it through the sinumeric post. And we see a lot of additional information specific for the 840D control. Now what controls this, much of it is extracted from the operation data, a lot of it is defined by the user. If we take a look at the operation itself, and I do look at the machine control events in there, these are the parameters that the user gets to set. This turns on the mode for the Siemens, and these are all the variables that can be set. And they're in terminology that's familiar to the programmer who knows the Siemens 840D control and what functions he wants to activate or not.
We see too often as well with some of the more simplest level of simulation that all CAM systems offer is what is called a toolpath simulation, and usually with material removal from the stock shape but no representation of the machine and its actual motion, often referred to as just regular toolpath verification. It's driven from the internal toolpath in most cases. Some CAM systems, however, though, today can offer a full machine tool simulation where we can see the part, the tool, the 3D model, all of it moving together. Impressive and more interesting than just the toolpath verification. but in most cases this is still driven in the CAM system from the internal toolpath data before it's been through the post-processing stage. In NX-CAM, when we need the machine tool simulation in the CAM session, we can run the operation set to the correct post-processor on the fly and use the G&M code output to drive the motion of the 3D machine tool. You know, the G-code driven machine tool simulation is it has to be a closer representation of what the real machine will do with the machining operation because it's driven from the posted code. And we see with other CAM solutions where you'll go out and you'll buy CAM software X, but then you'll actually go out and you'll purchase another toolpath verification software such as Vericut to make sure that the posted output is actually going to perform what's going on at the machine. NX-CAM, we can do all this with inside of one solution. Quick demonstration.
In this demonstration, we're going to look at the use of machining simulation inside NX-CAM. First, the user picks the machine tool on which he plans to run the job and selects that machine tool model from the library. The part can be transferred to an alternative machine at any stage. In this case, we're going to pick the 5-axis milling machine. It has a Siemens controller. And the programmer generates the toolpath of the 3D part model from the wide range of machining options, as we see on this complex impeller one. At any time during the programming, the machining process can be reviewed using the integrated simulation capability, and the system uses the appropriate post-processor for the selected machine and immediately prepares the G-code output to drive the simulation. And you can check for errors, such as collisions or limited travel violation. In the code display window, the user can opt to see either the internal toolpath data or the G&M codes from the post-processor output. These are the codes that are being used to drive the simulation, all inside NX-CAM. The machine tool 3D models are built using standard NX-CAD modeling and assembly functions, and then the machine tool builder option that comes with the NX-CAM allows you to add the full kinematics of the machine onto that 3D model, including the axes and the limits of travel and so on.
So for advanced machine tools, we can provide a complete solution, including a post-processor and a 3D model of the machine tool that can all be simulated through it inside of NX-CAM. So next, let's move on to programming productivity. With a simple or limited CAM system, you would expect to be an easy-to-use. Obviously, with less icons, less capability, the interface is a whole lot easier to adjust to. With NX, we invested heavily and applied the latest user interaction techniques across NX to ensure that the benefits of the advanced function of NX-CAM are accessible even to a new user, providing a shorter learning time and making things easier for the less frequent programmer. For instance, on the left-hand side here, or on the right-hand side of our screen, where it's showing the cutting parameter, basically anywhere inside that dialog box that you click, the image on the right-hand side will change, and it gives you a nice representation of what it's describing. New tools within inside of NX as well will allow for virtual jog mode for full control of toolpath and tool axis. Got a short demonstration here that shows what we're referring to.
In this short demonstration, we're going to show the graphically interactive programming that we have available in NX-CAM. In this case, the user is able to interact with the tool and in this case the tool angle directly on the screen to edit, or in fact as we see it, to create a new toolpath. In this case, to avoid a collision with part and component, we want to adjust the tool axis. We do that graphically, can do that graphically by interacting with these what we call grab handles relative to the tool, and changing its angle for the start and finish position. In this case, this passes the toolpath. Then the system recomputes the new toolpath, and we avoid the collision. In the second example here, we're actually using the same technology. We're using it to create a new toolpath. We're positioning the tool relative to the part graphically on the part, to create this tool path along the center line here. We can also use it to position the tool for retracts, as we show here, and therefore build up a complete tool path relative to this prismatic part. Again, a very useful tool, easy to use, to interact graphically on the screen to create a tool path in NXCAM.
One of the ways Siemens has enhanced the customer experience and shortened the learning curve is what is called the express role. And this gives the ability to select either the advanced or express role. Is provided standard with all versions of NXCAM. And this express role is especially aimed towards the new users, where it'll help change the interface, maybe make larger icons, to cut down on the different images that you have to remember, or where the location of different icons are at. The CAM Express role, again, geared towards the new user, but can move to what we call the advanced role as you become more custom with the software. The visual representation of the layout of the program is in a tree structure inside of NXCAM, which we see in the image here. We have the impeller and the multi-blade, a nice tree structure. The operation navigator itself keeps critical information accessible and facilitates reuse, so all your common cut, copy, paste commands can be done with inside of it for parts that contain features that are, a lot of the same features, I should say. A rich information environment displays the operation sequences and dependencies while tracking tool usage and facilitating associative part data. Across the entire user interface, we'll use the latest methods of making the user interaction fast and easy. And again, one of those was where pretty much anywhere you select inside of the cutting parameters dialog, the image itself will change, giving you a nice image to see what it is that you're changing. A simple example is the use of diagrams and menu dialogues to show user what is needed. Also for quick searches, the command finder, which is new inside of the NX, can take the programmer straight to a topic inside the system. So if we type in, how do I create a tool, it'll automatically go out, show you exactly where the icon is located for creating a tool, and it'll also give you step-by-step instructions on how to actually create that tool. Last but not least, we're going to cover integrated solution. So NX offers the option of a complete CAD/CAM system all within inside of NX. The full range of your CAD functions can be extremely useful for the CNC programmer. And with NX, it doesn't mean you have to jump from one CAD program into another CAM program. It's all within inside of one system. We don't have to go from our SolidWorks seat to a master CAM seat. We can do it all within inside of one tool. We can also expand out into other areas such as tool design, mold, die, or build out just a complete part manufacturing solution. So the latest CAD technology in NX enables the NC programmers to rapidly prepare part models, including third-party CAD models. This provides a wide range of additional manufacturing applications such as tool and fixture design. Let me show you a quick demonstration here of what synchronous modeling is.
NX provides powerful model editing functionality, and we call this synchronous modeling. It's available in the standard CAM packages, and it allows the NC programmer to make quite complex adjustments to a model prior to doing the NC programming. In this case, the user is going to select these whole features here and ask the system to cover them with a surface that matches the surrounding surface, making it easier to put a toolpath over those areas. In these second and third examples here, the user is selecting quite complex geometry and asking it for it to move to a new position or editing a critical dimension. The system takes care of the edit, even though the geometry surrounding it is quite complex. So this provides a very powerful solution for the NC programmer that needs to be able to use CAD functions in or before the NC programming task.
And keep in mind with what we just showed there in regards to synchronous modeling or synchronous technology, that's provided core with any seat of NXCAM, and it can be done to primarily any model, whether it be out of NX CAD or whether it be an imported file from, let's say, SolidWorks, a Parasolid, a DXF, STEP. We have the ability to use synchronous technology on any types of models. Siemens provides a complete solution set to define a part manufacturing plan and take it to the shop floor for execution. This diagram here represents our view of a complete part manufacturing solution. It extends from the part modeling preparation and design to the production on the shop floor. This solution combines the Siemens PLM software, manufacturing, engineering applications, and connects with the Siemens motion control, which we discussed in a couple of the demonstrations here this afternoon. It also includes the Team Center for some of the data process and management. So a quick summary of different webinars that we have coming up. This Thursday, actually, we're going to be going over high-speed machining in depth with NXCAM. Next Tuesday, July 17th, I'm sorry, a couple weeks out, we have the reduced NC programming time and also automated mold design. There's a little bit of an error on the top there. That's actually Thursday, June 28th versus July 28th. I apologize for running a little bit over, but I want to certainly thank everybody for their time here this afternoon. We did leave this open for Q&A. You'll notice on the right-hand side, if you have any questions, feel free to type them in, and we will do our best to answer them. All right, at this time, it doesn't look like there's any questions coming in. Again, want to thank everybody for their time. My contact information is on the screen there. If you have any questions, feel free to give me a call directly. Shoot me an email. Here to help out in any way. I'd like us to come on site and do a customized demonstration of NX with maybe some of your part data. Feel free to give me a call, and we can go from there. And thank you much, and talk to you soon.